So, Stefan, we have used AI technology to classify products and photos, as not always our customers use the same naming conventions to describe the category, gender, or age of a style. Or if a photo is a pack shot or model shot, and what angle it is always not described in the same way either. I mean, if it's described, that's of course amazing, but it's many times not even available, that information, or in some cases it's not correct. And we need to know these classifications in order to develop many of the features in the applications, but also other interesting AI applications that require this information. So can you share our learnings on how to achieve a consistent and a reliable classification of the content that the brands sends to us?
Mm-hmm. Sure, of course. Let's have a look at image classification. And might sound a bit dry at first, but it is actually, I would say, one of the most useful things, or one of the most useful things we actually have for quite a while now. And it helps with different things, as you already mentioned. And I think we will go a bit into details also, like how to use it. But first, maybe I want to explain just quickly what it really means on a technical basis, basically. So I have prepared one example here. So usually what a classifier does is it assigns a class, or you can also say a label to, in this case, an image. So here we have one image, and then just to show that visually, here we have basically different classes that we say are generally, these are basically the candidates that it can pick from. So we say, okay, there are, in this case, 5 different labels you can choose. And here's the image. Which of the given labels is the one that matches the image the best? And then it will pick that. So in this case, we say we have here a lot of combinations of model, the gender, and the age, for example. And then here in this image, it would say, yeah, with pretty much 100% certainty, I would say this is a woman, adult, and, well, it's a model. It's a person, obviously, yes. So here, that was correct. Mm-hmm. So that is just generally how classifiers work. And of course...
Who creates these labels or classes?
Yeah, exactly. That is where we then already go into how to actually create such a classifier. There are also different types of classifiers. We will talk later also about some which are a bit more, let's say, generic. But here we start with this, in quotes, simple ones. This is also when generally, let's say, machine learning and vision kind of started to become big, basically how it started. And these are, the special thing about these kind of classifiers is that you train them on a very particular task, which also means you prepare different classes that make sense for your use case. So in this case, these are the classes that we picked. And then it will also only know these classes. And we can jump here. So just to go a bit back in time to just briefly show you the history of this also a bit. So you see here around 2016, that is also, I think, where we started to first look into it a little bit. So this is kind of where all this came up. And what is interesting here is to just see kind of the trajectory. You also see, since roughly year 2020, 21, it feels a bit like we're hitting a bit of a plateau. It's just increasing slightly, but it's also, we are actually becoming pretty good. Here, also why I brought it up. So most classifiers are evaluated or also trained on something called ImageNet, which is essentially a data set that was prepared a long time ago, around here, which basically tried to find or to categorize images of our world, more or less. In the end, it didn't turn out that it really mapped the whole world, but it is essentially a data set of 1,000 different classes. I also have actually the classes here. And then they collected images for all of them. What is interesting, though, this data set is it's diverse, but also not at the same time. So you see here here a lot of different animals, for example. Each line is one class. So you have a stingray, you have a dog, but then also if you go down here, you have actually some very interesting things. So these are all animals. And then we
There
come
are
into...
many animals in the world.
I mean, that's true, of course. There's also, of course, one person, like a human class. But then you also have things like croquet ball. Don't even know what that actually is. Or you have a dining table. Of course, that's kind of common, but then also face powder or espresso maker. So some things, they feel very, very specific, and also, okay, why did they pick this? So that is good to have in mind, that most of these classifiers, sort of the base was trained on often this kind of data set, which means they have a bit of understanding generally about the world, but then also sometimes they can be a bit weirdly knowledgeable about, for example, obelisks, but then they might also, again, not know about other kind of classes that we would think, okay, they're actually pretty common.
So what you're saying is that they haven't necessarily been specialized in the fashion domain.
Exactly. So that is also a thing to know about classifiers in general when it comes to actually using them, that that is definitely one type of models that you usually have to fine-tune yourself. Otherwise, because they're so generic, it is pretty much kind of mandatory to fine-tune to make them useful for you. And that is also then what we did, of course. So if you want, I can also show briefly how practically that works.
The fine-tuning, how to fine-tune?
I mean, we will not actually run a fine-tune, but the most important thing is usually also before that to collect the data set. So I could, just to give an idea how such a data set looks like. So this is one of the data sets that we used. And you see here, I mean, there's actually software, there are tools for that you can use. Personally, I found it actually more straightforward, especially if you're in a small team. If you are dozens or hundreds of people, then it makes sense to have some kind of software set up for this. But if you're just a group of people, you can just use your folders on your computer. And in the end, it's about naming. When you create a folder, you name it with the class name, so to say. And then
so this is where you define the label, so to say.
Exactly. So, and then you see inside there are simply a lot of images, so a lot of examples. So generally how fine-tuning works is to say, okay, here is a class, and here are examples of that class. Here's another class, other examples. And then during the fine-tuning, the model will basically now try to figure out what are the really the features or the differences within the image that makes this class, and the other one makes it that class.
So let me guess, this one is it says back and the full perspective.
Exactly.
Of a model shot.
So, exactly. So I can actually jump to that already then. So we have, here are 3 typical classifiers that we have tuned for tasks that we need a lot. And these are, of course, very much now tailored to the fashion domain. And let's start with this one. So I can also show you how it really works. So here we have a bit of a demo interface. What I can do here is simply to give it a picture. So let's see, I think I have, let's use it. So I give it this picture. So as the name suggests, here it's about figuring out or classifying the gender. It's more of a range of age also together. Why together? I will also mention that now. Here you see, okay, as expected, that worked pretty well. 99.9% confidence. One thing here to understand, or what's important to realize, is that these classes, they're exclusive. So, which means this classifier will never say, okay, it is a male for sure, or a man, and at the same time, it's a woman. So you cannot basically have 2 classes totally up. Here you see the numbers. That is basically the a score that it's assigned. So 1 is the top score that one can have, and while the others have 0. But they always sum up in total to 1. So they can never score on everything fully.
Okay, so it could be 50% man, 50% woman. Basically, it's hard to distinguish in that picture.
That could happen. Also, that being said, and what it practically means, what is the important part always to have in mind, is that you need at least one class that is sort of the the other stuff, because you always have to keep in mind there can be images that do not fit into the classes you're actually looking for. So when we trained this one, we mainly wanted to know the person, the gender and the age, but you might also send in an image which actually shows a t-shirt. And then, of course, it needs to have something to pick as an alternative. And that's why we also have a pack class here.
Okay. Yeah, otherwise it would just have to pick one of the labels and say that this is the most probable one and skew the data.
Exactly. So, I mean, to just make that point here. So, I mean, even you can go even further and show an image that is like very much unrelated to fashion. So let's pick the banana. And here, yeah, it would say, okay, this is a pack shot. Which, if you think about it, actually also makes sense, because what typically a pack shot means is you have one product, usually in front of a white background. So, and the focus is very much on the product. So conceptually, it actually makes sense to say, okay, out of these choices, yeah, I would pick pack shot for the banana.
But it would have made sense, not that our customers and the brands will send us bananas, but it would have made sense to have one more label saying like other or unidentified or something like that, so that we can also distinguish that this is for sure not a pack shot.
Absolutely. Though, I mean, it always depends here. I mean, usually these classifiers you train for a very particular thing. And here it's mostly, I think in our case, it's mostly about being able to filter, okay, now I want to see clothes for women, for example, that we simply have that label on the images. And also, as you mentioned, I mean, of course, usually in the data that we get from our customers, there is, I mean, at least the gender is usually mentioned. However, again, not always. And also what we know is, I mean, sometimes people make mistakes, especially if it's labeled by humans. And with a good classifier here, we can exceed the human performance. And especially the main difference is, because that's the thing also, I mean, creating these kind of data sets, I mean, I mostly labeled all of these images myself. And we are talking about 70,000 images here in total. It takes a while, and I can confirm it's actually pretty, it does something to your brain if you look for half an hour on the screen and just look at those images. So you will make mistakes, because as humans, we just get tired, while a model never gets tired. So it will always perform in that sense the same way.
Correct.
I can show you maybe quickly what else we have trained. So another one we use a lot is perspective. What that means, I can show you here, for example. So again, a model wearing a t-shirt in this case. I can show you, I mean, here I have a snapshot of one of our applications. So where you typically need that is if you have, let's say, your e-commerce website or the app in your showroom, etc. You want usually that one kind of images comes first. Can differ from brand to brand. I mean, some prefer, like, say, the full model shot. Others, I mean, here it's more kind of a close-up. Some would show the pack shot first. That can depend, but what you want is that the order is always the same. So for this product up here, you want to have the same order of images like down here. So, and for that, to make that work, of course, we need to know on the image, somewhere there needs to be information, okay, what is now the perspective here? And this is what we do automatically.
Yep. I mean, you can achieve that by numbering. I know a lot of brands just number their images 1, 2, 3, 4, 5. It works as long as it's your own application, you have control over it. But if you would connect it to a third-party application or a plugin or something like that, now you have to like remap and understand that third party's structure, so to say. While in our case, you just send the data to us and we kind of figure out no matter how your labeling is initially.
Exactly. And sometimes, you know, I mean, especially in enterprises, that they have so many people, so many different teams working on things, then one team might decide, okay, now we change the naming convention. They might internally maybe tell another team, but then they might not tell us. And then next day, everybody wonders why now we always see the backside of the models. That is the thing. That's why we want to not rely on these kind of custom naming conventions. And yeah, you see, as expected, I mean, that worked. Here we have, I mean, generally front, back, side.
Sorry, Steffen, just to mention also that this type of classifications could save brands a lot of time in the early on in the process. Having someone having to name and layer them, or 1, 2, 3, 4, whatever, just
Mhm.
takes time. I mean, run it
Yeah.
through one of these classifiers, and the output is like instant.
hmm Exactly. I mean, that's also a good point to mention here. I mean, before we talk about other models, they actually take some time until you see a result. The nice thing about these kind of classifiers is they are, in that sense, very, very efficient, also in terms of time and money spent. So you see down here, actually, it's very small. It says that was 400 milliseconds. So it took to classify this image. So it's barely noticeable. And at the same time, also, it does not use a GPU. So it runs on a normal processor, which also means it's like much, much more cost effective.
Yeah. And you do it once.
Exactly. I mean, usually, of course, we do it once and then we remember. So you can classify a lot of images automatically by doing this. Yeah.
How much effort does it take besides labeling to prepare the content for fine tuning? So is it just a matter of labeling and putting them into the right folders? And also then how long does it actually take to fine tune one of these models?
Yeah, it depends, of course, a bit on the particular case. The more examples you have, the longer typically also the training takes. So it can be from some hours to potentially days, the larger your data set is. Then you also have usually some parameters. I mean, you see actually down here, they kind of mentioned. Basically, some settings you can, beside the data set, you also give these kind of parameters to the training, the model. The thing is, often you have to try out simply a bit. So typically, you do not run just one training. You do several in parallel, and then you tweak these parameters a bit. So for one training, you set this maybe twice as much, for the other half. Then in the end, you do some evaluation. That is basically what you see down here. So you see basically the accuracy you get out of it, and then you pick the one in the end, of course, which performs the best. So this is how you would typically do that.
How do you do the evaluation? I mean, because once you do the fine tuning, I guess you have to then send it a couple of test images or photos and see if it would tag it correctly or not. So how do you evaluate?
Yeah. So how that usually works is you have your data set. So now we have here the class model back fold, for example. And what you would do before you start the training, you take a portion of this and basically put it aside. So the largest portion you use for the training, so let's say 80%, for example, of all the images you take, so you show to the model during training, and then you keep 10% you just aside, so the model during the training never sees those images. And then after, or even during training, you once in a while, basically you show it one of your test or validation images and see what kind of class it would now assign. Since we generally know the class and we labeled it manually before, we can then evaluate, okay, was it right or wrong? Then that is basically how you get that score. And that is also important to be able to know. I mean, does it become better or worse? And also over time, you might spot cases where it mislabeled an image, especially in the beginning, of course. And then you can take these images or these examples you discover and put them aside, and then later add them to the training set and rerun the training so that it learns basically from those mistakes as well.
All right, cool.
Then I can maybe show it. This is a bit more interesting one. I mean, the other cases, they are very important. I mean, we use them a lot, but they're also quite straightforward to think about. Here's one which is a bit more maybe special. I can quickly just bring up one example here. It's called pack types. Doesn't say so much. Maybe just the name. When we see the classes, I will explain what it means. This is something we started looking into. This is mostly what you would use, for example, for recommendations like complete the look. So you have one item, and now you want a recommendation system that for this item basically creates the whole outfit around. So here we need to know, or what usually plays a role in an outfit is the layering. So typically you have, for example, like a t-shirt, and then above the t-shirt you might wear a jacket, or you have a hoodie and then you have something on the hoodie. I mean, this kind of layering is important, and it's important to know. Then, of course, I mean, this item here, I mean, which layer is that? So you cannot pair a t-shirt with another t-shirt, because I mean, you can't, just look weird. So that's why we train this classifier. So here you see pack top 1 and L2. And there's even a third layer. What it means, I mean, a t-shirt, that is basically the first layer you typically have on your body. So that's why it's called L1. And then a hoodie, for example. I think I even have a hoodie here. So it only works with pack shots. So hoodie should be L2. Yeah, L2. So here it basically classifies, okay, you show the pack shot, and then it classifies, okay, which kind of layer is it in your outfit, essentially. So,
and there is, again, the same concept, right? So you create a folder called pack top L2 or L3, different folders, and we push like a lot of these pack shots into each folder and then run the classification training.
Yeah, exactly. So this is pretty much, I mean, the nice thing is that it's pretty straightforward, generally, the workflow. And also it's very, as we said, it's also very fast. And also it's very, I mean, pretty deterministic. I mean, in the same image, you run it 100 times, you always get the same result. Good. So, and that makes us really suitable for, I mean, workflows where you have to do a ton of image processing, and you don't have to worry about, I mean, too many moving parts, simply. Then there are some alternatives, though, nowadays. I mean, as I said, I mean, these are kind of the, in quotes, the old ways or the old classifiers, but they are still, I mean, not old in terms of bad. They're actually very useful. But nowadays we have more options. So something called zero shot can again bring up the hoodie. So what zero shot classification means is here actually you do not have predefined classes, or you can actually get results. It's more flexible. So I can show you that. So here, because you can provide the classes when you make the classification. So here, for example, you could say, okay, hoodie, that's pretty much what it should find out in the end. But you can also say, okay, another option is t-shirt, or maybe jeans, or let's use the banana again. So you provide the classes with the image, and now it will basically on the fly figure out, okay, which of these that you provided is the right one. So now that model needs to spin up a little bit, but there we go. So also here it worked. Here also one difference is to the one we showed before. Here actually it can score on several at the same time. So it's a bit different. So
when would you use this type of model compared to the other ones?
That's a good question. So also the next one that I'm going to show, I think these are very good. I would personally use them for mostly experimentation. So sometimes you have maybe some idea or some concept, and then you want to figure out, okay, how would it feel, how would it work? And then, of course, I mean, to go through the whole process of labeling thousands of images and do the tuning, etc., it takes time. That you can do very, very much easy and doing something like this. Okay. The downside is they are not usually as accurate. Also, I mean, they take a little bit more time already, and generally it's not as the quality you get out of it is not necessarily as good.
Good.
I mean, everything that is very specialized usually performs better. So, and then just to go full circle, and then we have nowadays also vision LLMs. That's sort of the next level of flexibility, but also complexity. So they also, I mean, you already see it takes longer to load everything. What I can show you here is, and this is sort of like what you could also do with something, for example, ChatGPT. Here, the nice thing is we can actually compare a lot of different vision language models. Difference here is now here you actually have to give it like a whole instruction. So not just the classes, no, you actually have to describe what you want to do. So you could, for example, do something, is the shown item a hoodie or a jeans? So you give it the question. say send. There you see already, takes longer. And okay, this case it didn't even work at all. But here, you get then an answer. So sort of, what you would expect from a kind of a chatbot. So this is the next level of flexibility. You can, of course, also ask it all other kind of stuff. It's not just about what class it is. You can ask it what occasion can you wear this, etc. So it's very, very flexible, but that's also the problem. The data is not very precise. Also, now you need to parse this somehow because what you're interested in is just knowing hoodie.
So from a classification point of view, it might be relevant to when building applications where the user is offered choices on the fly and dynamically, and it can really change more nuances than what you had trained it for. And it also, as you say, like you don't have to do the whole trouble of creating folders and then finding the images and putting them in there. Got it.
Exactly. So, where they are also, another use case, maybe we talk about that some other time. Sometimes you also need to have more of a description of the item. That's actually where these models are quite useful. So if you want to have a description, okay, this is a green hoodie with some print on top. Maybe it has some pattern and describes the pattern. For that these are perfect. But for classification, maybe a bit overkill simply.
Okay, cool. These are. Do you have anything else, by the way?
This is what I have prepared so far. If you have questions,
I think it might be worth mentioning that, especially regarding the classifications, both layering, the gender, age, front, back shot, or if it's a model shot and so on. These are all services that we have built into our platform. So all of the media that our customers are sending us is being run through these classifiers. And if there are any applications either within our products, tools, or if there's anything outside, this would also be possible for the customers or the brands to actually retrieve the information back and do something with that data if they would like to, right?
Exactly. All of these we can basically connect then again to your system, where you connect your system to ours in the case, and you can pull basically the labels, for example, and feed that into your own systems as well. So we can basically replace the whole, if there is a human labeling crew.
We don't want to replace Steffen, but we can enhance the ability capacity, right?
Absolutely. The thing's also sometimes, of course, it's good to still have a human in place that verifies the output. It's just, of course, much easier if you say, okay, here are all the images that the model believes are of this and this class, as a human to kind of browse through. Then you usually spot the differences quite easily. But it's much easier than if you actually have to sort them yourself first.
Yeah. No, but one should not underestimate the utility of the classifiers. There's so many places when we're trying to figure out the shop the look, complete the looks, or just find similarities to sometimes remove the background, and really make sure that we increase the probability of the experience and the features later on in the stages to have a proper way of classifying stuff in the beginning.
Exactly.
All right. And with that, thank you, Steffen, so much for sharing more insights.
Of course. Always a pleasure.